Excel has several functions that you can use to to get values related to the chi-squared distribution. And again, if you've watched any of the previous Excel lectures, the one on the t-distribution or the one on the normal distribution, the functions here are going to be very familiar. If you want to find the area below a given chi-squared value, you'll use the function equals chi-squared dot dist. And hopefully, again, if you've watched those previous lectures, this is very familiar. All of these distribution-related functions follow the same pattern. They start with some kind of abbreviated name of the function, dot dist for distribution. And I'll put some numbers in here. Let's say we want the probability less than 1, 10 degrees of freedom. And again, just like with all the others, if you want a probability, this cumulative parameter is going to be true. Cumulative as in add them all up, right? This adds up all of the values below 1 for this function. Again, just like in the previous lectures, I've got this Excel set to show us the formulas rather than results, so we can just kind of keep these in front of us. Now, we're talking about chi-squared distributions. If you want to get the area to the right of that value instead of to the left, that's the probability here in cell A5, the probability of getting a result greater than our chi-squared value. Well, I'm going to do chi-squared.dist.rt for right-tailed. Right? And I'm going to put, let's put the same numbers. Let's put 1, 10 in here. And now think about what I've asked it for. In the first row here, I've asked it for the area below 1, and in the second, I've asked it for the area above 1. So when I show the values here, these two numbers put together should be everything, right? They should add up to 1, and you see they do, right? We can test this real quick. Equals, we'll add them up. Yes, we do end up getting 1. All right, so that's probabilities. Right, and again, just like in all the others that we've looked at, using this dist formula gives us a probability. So to find chi-squared values, chi-squared scores, right, I'm going to, again, do the exact same thing we've done before. I'm going to use chi-squared dot inverse. And that's going to give me the chi-squared value that has a probability to the left of it equal to what I put in here for this probability parameter. So what I'm going to do, just again kind of testing things out, I'm going to give it this probability that we calculated up here. And I'm going to give it the same degrees of freedom. So this should give me 1, right? It should give me the chi-square value that I used up here, and we can turn this off real quick, go and look at the values. Yes, it does give me that value back. And again, remember that this chi-squared, it's not a symmetric distribution. So if I want to find the chi-squared value that gives me the area to the right, I'm going to do the same thing. I'm going to do chi-squared dot inverse dot rt for right-tailed. And now let's give it this right-tailed probability that we calculated. And again, if everything is going as planned, that should also give me the chi-squared score that I entered up here. It should give me 1 also. And yes, there it does. Now, one thing, keep in mind, because every once in a while I'll see students get thrown by this. Remember, the chi-square distribution is a little unusual compared to what you've already seen with the normal and t distributions. The chi-square distribution does not take negative values. So if I come up here and I say chi-squared dot distribution, and I try to give it a negative chi-squared value, you see already it's giving me a hint. I don't know if you can see this little tiny green triangle up here, right? That's Excel's way of telling me, look, I know you want to keep looking at the formula, but I'm just trying to give you a heads up, something went wrong, right? And whoops, sorry, didn't mean to drag that around. If we go back to looking at the output, you'll see it's giving me an error message because, again, you can't find the chi-squared. You can't find a chi-squared probability for a negative chi-squared value. That's outside of its domain. All right, so let's get that out of there. Okay, so again, you see same pattern here, right? If you want to find a chi-squared score, then just like we've seen in the previous scenarios, you use this inverse function, the inverse versions of the chi-squared functions. Now, briefly, just before we wrap up here, I want to talk for just another minute about this true-false cumulative parameter here, because I've kind of just politely ignored it and just said, yep, put true. Okay, what happens if you put false? Well, remember, there are formulas that are used to describe the graphs that we've seen for these distributions. They're usually a little on the unpleasant side, right? And so we don't usually talk about them very much, but these probabilities aren't just coming out of thin air. There are formulas for these functions, for these distributions that we're using to do this. To find a probability, what you're doing is you're adding up all of the values of that function above or below your chi-square value, your t-score, or your z-score. If for some reason you really just want to know the value of that formula, the height of the curve, if you will, for a given x value, that's when you would put false in there. All right. Now that's not something you're ever going to have to do in an introductory statistics class. That's why I keep saying every time this comes up, you always put true in there. Okay, because for our purposes, finding probabilities, that's always going to be the case. But again, just kind of here at the end of these this series of Excel discussions, I did want to just kind of briefly mention what that false value did, just so you can kind of have an idea of why that's not what we want for the situations that we're looking at.